So what makes a good goal? Well, before we answer that, let me ask you another question. Are all goals created equal? What do you think? Listen, goals do differ in the type and the depth of learning our students experience. So let's take a look at the different types of goals and talk about the learning that takes place within each type. There are performance goals, and then we have learning goals. And each of these types address learning differently. And let's see what those differences are. We'll start with performance goals. Performance goals focus on the mathematical procedures only. These are the students will be able to statements. And under a performance goal, students are restricted to using just the procedure that's identified in the goal. Students are assessed based on their computational work only. Performance goals don't address the conceptual understanding that's required by our standards. On the other hand, learning goals focus on what students will understand from the lesson. The key word here is understand. The focus of the learning goal is to build conceptual understanding of the relationships that drive the procedures. And they also support procedural fluency and application. Under a learning goal, students are assessed through demonstrating both an understanding of the concept, explain or justify your reasoning, as well as through computational work. So learning goals support the procedural, the conceptual, and the application aspects of the standards. Here's an example of a performance goal. It says students will identify a function of the form y equals b to the x as an exponential function where x is the exponent and b is the base. Students will be able to substitute values for x and b to evaluate exponential functions. The focus of a performance goal is the procedure. And in this goal, students are only required to recognize that a function that's written like y equals b to the x is an exponential function. So under this goal, students are not required to understand the relationship between quantities in an exponential function. So when an exponential function is represented in a different way, such as a graph, a data set, order pairs, verbal description, students are not going to be able to recognize it based on the learning in this goal. In addition, this goal focuses on one procedure, evaluating exponential functions by substituting values for x and b. That's basically memorization. Now let's take a look at a learning goal. This learning goal states students will understand that exponential functions grow by equal factors over equal intervals, and in the general equation y equals b to the x, the exponent x tells you how many times to use base b as a factor. Notice the learning goal addresses the conceptual understanding of what it means for quantities to be an exponential function, that the function values grow by equal factors over equal intervals. Now students still must know that y equals b to the x is one way to represent this function, but they must understand what that means, that the exponent x tells how many times to use base b as a factor. And students who have that understanding are better able to recognize relationships that are exponential and apply that understanding. Now, when we compare these two goals, under which goal would the deepest thinking, the deepest learning take place? Well, hands down, it's the learning goal, right? Now, let me say this clearly. Procedural practice is necessary in mathematics learning. There is a time and a place for learning and practicing procedural skills. However, in general, learning goals generate deeper thinking and learning because they support developing our students' conceptual understandings that are behind those procedures and applications. Now let's compare these two types of goals to the standard that they align to. Both of these goals align to FLE11, which says students are to distinguish between situations that could be modeled with linear functions and with exponential functions. A, prove that linear functions grow by equal differences over equal intervals. B, recognize situations in which one quantity changes at a constant rate per unit interval relative to another. And C, recognize situations in which a quantity grows or decays by a constant percent rate per unit interval relative to another. Whew, that was a lot to read. So which one of these two goals best supports the learning that's identified in this standard? I think we can agree that the learning goal does the best job of supporting the learning in this standard. And even though the learning goal does not address the entire standard, the learning that this goal would support would be the first in a series of lessons that work together to build students' understanding of this standard when it comes to exponential functions. Both of the goals align to the standard, but the learning goal was written with the standard in mind. So we would say that it's a standards-based goal. And on that note, let's talk about standards. So our standards goals. Well, if we go back to FLE11, it would be impossible for us to teach this standard in a single lesson. And it would also be impossible for our students to learn everything in this standard in a single lesson. Most of the time, our standards are far too broad to be the learning goal for a lesson. So learning goals would need to address the learning of our standards, but in increments with a sequence of lessons that build that understanding over time. And with some of our high school math standards, the full learning identified in the standard is achieved over a sequence of courses. So some standards are far too broad to be learning goals. So when we're developing goals, we need to be clear about how the learning goals relate to the standard and how they build our students' understanding toward the rigor that's identified in the standard. In this next activity, we'll be comparing goals and discussing the learning that takes place in the goal to determine if it's a performance goal or a learning goal. After the activity, we'll take a look at writing effective goals.